Hi there, this is Forces Lesson 6, and this is the second part of resultant force and acceleration. So the objective for this one is to explain what resultant or unbalanced forces does to an object in terms of its acceleration. So this is like the weirdy part of it. So force, just to reiterate, force is a push or a pull, which can cause an object to do one of four things: speed up or accelerate, slow down or decelerate, change direction, or change shape. We can also measure forces using a Newton meter. There's some examples of some Newton meters on the right that you might have seen at school. So resultant force. So to reiterate again, the number of forces acting on a body may be replaced by a single force which has the same effect on the body as the original forces all acting together. And the overall force is called the resultant force. So in this example, we've got a 3 Newton and a 2 Newton force acting to the right. They're the component vectors or the component forces. And they simply add together to give a resultant force of 5 Newtons. So what you can do is give this a pause if you want and solve these. And I'll go through the answers. So the first one, so 4 and 6 to the right, simply give us 10 Newtons. This one is 4 minus 3, which is 1 Newton to the right. So this one would give 4 Newtons down. This one you should get 4 Newtons upwards. And this last one, the 4 and 4, will actually cancel out and give a resultant force of 0 Newtons. Let's keep going. So in an exam, you might get a scenario, it might give you something like this and then ask you what's happening. It will give you a bit of obviously more information. But in this one, we've got the push force pushing to the right and the frictional force opposing that motion to the left. Now, according to the size of these arrows, we can safely say that the push force and the frictional force are equal, yet opposite. So the exam might give you a number and then give you one of two scenarios. So the first one is that the box is actually stationary, and an explanation, a full explanation, would be that the push force and the friction are equal and opposite. Therefore, the resultant force must equal 0 because they're in opposite directions, so they'll cancel each other out. Therefore, there's no acceleration, so this box will not accelerate. Therefore, the box will remain stationary. So that's one scenario. Remember, the no acceleration just comes from Newton's second law, F equals ma. So if you've got a resultant force F that's equal to 0, there'll be no acceleration. So there's a second scenario, or second situation 2, where the box is already moving at a constant speed. So in the exam question, it might give you this diagram and then say, this box is being moved at 1 meter per second, or whatever it might be, and then ask you what will happen. And what people sometimes do is they'll see the forces, say, this resultant force equals to 0, the box is stationary. However, if the box is already moving at a constant speed, the push force and frictional force are equal and opposite. The resultant force is equal to 0, no acceleration, which is the same as situation 1, and the box will remain moving at a constant speed. So they're the two things that can happen. When you get a balanced force like this, the box will essentially do what it was doing. So if it was already stationary, it will remain stationary. If it was already moving at a constant speed, it will carry on moving at a constant speed. So I hope that's helped. They're kind of like exam solutions, the resultant force is 0, no acceleration, then making a statement about what will happen. So if you want to make some notes on that, please pause and please do so. So what might happen in this scenario? So in this scenario, the plane has an engine force that is much larger than the drag force. So if you want to write out an explanation of what might happen, if you imagine it's an exam question, Let's pause and have a go. So basically this one will result in a resultant force that is to the right, because the engine force is larger than the drag force. In this instance, the resultant force is not equal to 0. The plane will therefore accelerate. So that's kind of an exam solution. You know, you might get that, and a poor answer would just say the plane will move to the right. You know, you might not even get 1 mark for that. So it's this kind of answer that we're looking for. So we've got one more that we can do. So what about this one? So you should get a gist of what's happening now regarding the types of answers if you want to pause and have a go at this one. So on this one, we've got a large braking force. There's no driving force, so obviously, you know, when you're driving a car, you take your foot off the accelerator and put the brake on. So in this one, in this scenario, the car has a large braking force and no engine force as it approaches the red light. So it results in a resultant force to the right. Therefore, the resultant force is not equal to 0. So in this instance, the car will accelerate, but it will slow down, so it will decelerate to the right. So let's consolidate. So if you've got 0 resultant force, the effect on the motion of an object, the object's velocity stays the same, including staying stationary. If the resultant force is in the direction the object is moving, then the object will accelerate. And finally, if the resultant force is in the opposite direction in which the object is moving, then the object will decelerate. If you want to pause and get that down, that's okay. Let's move on. So what you can do is have a go at this without the keywords. If you want to pause and do that. I'm going to put the keywords on in a second if you need some help and you want to fill it in. This is a closed exercise, consolidation. And if you want to write this down in full, you can. If you want to do 1, 2, 3, 4, 5, 6, 7, 1 to 8 and just write down the keywords as a plenary exercise, that's also okay. So I'm going to put the words on now. And then I'm going to go for the answers. So a single force called resultant force can be used to replace a number of forces that act on a body. If the resultant force is 0, then the body will either remain at rest or continue to move on at a constant velocity. If the resultant force is in the same direction as an object's motion, the object will accelerate, and a car is decelerated when the braking force acts in the opposite direction to the car's motion. So I hope that's okay, I hope that makes sense. Thanks for watching, and I'll see you at the next video.